Alright, this is a lesson on 6.1a, and the way the software does these problems, I think they do a pretty good job explaining it. I'd like to add a little bit of my own information to it. Um, this section talks about greatest common factor of two or more terms, and so you're going to be presented with different examples that you have to try to identify common factors, and then based on common factors, determine the greatest common factor. And when I do this process, a lot of times for me, I'll do it a little bit different than the way the software does it. I'll say, look at the regular numbers, and look at the smallest of those regular numbers. So the 12 that's out front here, the 24 that's here, and the 60 that's here. Focus on the smallest number and say, does that number divide into the others? If yes, then good. If not, then look at some of the factors of this, starting from largest to smallest, and see if those will divide into the other numbers. Sometimes you can get away with doing that. When I do that, I see that 12 divides into 24, it divides into itself, it divides into 60. So 12 is going to be part of the greatest common factor. And then look at the x's and y's. Make sure they all have x's and y's, and then if they do, what's the amount that's shared between all three. This particular value doesn't even have any x's and y's, so really the greatest common factor is just going to be 12, based on just kind of talking through it. It doesn't have any x's and y's like the others do. But what the tutor mode will show you is basically that you can take each of these values and break them down into their prime factorization. And what that means is if you take 24 and imagine doing a little factor tree. In fact, what I'll do is I'll stop the video for a second and create a little factor tree for you. Okay, we're looking at the example that has 24xy, 12xy squared, and 60. And with the numbers 24 and 60 at least, I just want to kind of show you. If I wanted to figure out the factors of 24, I could say 8 times 3 is 24. So I'd come up with two factors that multiply to give me 24. And then I'd keep splitting it down for each composite number that I've got. If I have a prime number, I stop there because I can't split that number apart any further. But 8 is composite because it's 4 times 2. And 4 is composite because that's 2 times 2. So this is called a factor tree, and on the very bottom, what you should end up with are prime factors, which are the smallest pieces that you can get that when multiplied together give you the original number. So 2 times 2 times 2 times 3 is the prime factorization of 24. We came about that from a factor tree. Same process with 60. I could split that down as 30 and 2. 30, oh, I lost my lines there. 30 becomes 15 and 2. 15 becomes 3 and 5. So 3 times 5 times 2 times 2. Prime factorization of 60. So if we go back to the problem, if you do the step-by-step the way the software describes it, they'd want to know, what 24 is, and remember that we found out that it's 2 times 2 times 2 times 3, and there's a couple more boxes here because x and y are also multiplied with those pieces. Abstractly, we even have those factors. So we've got this prime factorization for 24xy. 12, if you made a factor tree for that, you could say is 4 times 3. 4 is 2 times 2. So it would end up being 2 times 2 times 3 if you did a little tree out there. And then what's the rest of it? X times y for the xy squared. 60, remember what we did for 60. We had 2 times 2 times 3 times 5. So we'll type in 2 times 2 times 3 times 5. Alright, so we've got all the prime factors. I'll say submit. Okay, they say, is there more than one factor common to all of the terms other than 1. So what they're getting at is that if there were nothing common for all three, your greatest common factor is going to end up being 1. You'd answer no to this question, and then you'd say 1 is the answer. There are values that are common, though, so I'm going to say yes. And they would say, what are the common factors? You don't need to use all these boxes. They're trying to say it may be something less than these 5 boxes. You have to look. So I'd say, well, they all have a 2 in common. 2 is a common factor. They all have another 2 in common. 2 is a common factor again. Alright, I don't see a third 2 in these guys, so we can't say 2 again. 3 is common 1 time. So they all have a 3 in common. 5's, x's, and y's, they don't all 3 of them have those values in common. So remember the first time I talked through this, I said 12 was the value that divided into all of these, and that was the greatest common factor based on the way I talked through it originally. Look at the factors here. 2 times 2 is 4, times 3 is 12. So what you're going to end up with is a final solution, either way, of 12. Okay. Let's see if we can look at another example really quick here. Alright, for numbers like 21xy and 42, you could do the factor tree out for each one and make a comparison. What I see as kind of a quick way to do it is that 21 is the smaller of the 2 regular numbers, and 21 divides into itself, and it divides into 42. So I'm expecting 21 to be part of the answer. 42 doesn't have any x's and y's, so there's nothing common, so I'd expect 21 to be the greatest common factor. Okay, these numbers, negative 15, negative 91, and 38. With the negatives, it's just kind of a little technicality, I guess. If all 3 numbers are negative, then Hawks chooses to make negative 1 a common factor and will express that as part of the product, the final answer. But if not, like this example has 2 negative numbers and a positive, they're going to have the answer be positive when they enter it in. Just a little technical thing that they're focused on. But, you know, we can do the same process I talked about where you could look at the numbers and say 15, 91, 38. I don't think 15 divides into these guys, so I would think of other factors of 15, 5, 3, and then 1 lastly. 5 wouldn't divide into 91 or 38. 3 wouldn't divide into 91 or 38. So 1 is what I'm expecting as a greatest common factor. But if you go through the tutor mode, they're going to have you break down each number with factor trees, like, prime composition, and then you would come to the conclusion that there's nothing common between all these values. So we could say submit. Okay, 81 and 27. Does 27 divide evenly into 81? Yes, it does. And it divides into itself, obviously, so 27, greatest common factor. Okay. This one here, let's see how we're doing for time. Guess we're out of time, so we'll do this on the next video.